in next 20 minutes or so, we are going to talk about how to build a scalable Web3 backend for your dapps using something we call Web3 Actions. So the talk is split up into 3 different parts. One is just to introduce you to Tenderly and what we do. Then we are going to switch gears and talk about what actually are Web3 Actions and how to use them, when to use them. Okay, thank you. When to use them, and then we are going to put everything into context and actually go through an example of applying Web3 Actions to something that can be considered a real case. But before we start with the real part of the talk, I just want to give you 2 disclaimers. First, yes, we are going to talk about the product that we are building, so there will be some shilling about the company, but I'm trying to keep it as minimum. And another one is the talk was supposed to be a workshop, so there will be code samples and so on. And I'll try to keep them, an explanation of them as bare minimum. And if you have any questions after the talk, please reach out to me and we can discuss the examples afterwards. Cool. So Tenderly began its journey in Serbia, and we are now about 60 people strong. And our goal is to build an ecosystem for Web3 developers with all the tools to ease your pain and make your Web3 journey and deployment of your applications as easy as possible. And here are some of the tools that we already built. One of which we started with is Debugger, which allows you to debug your smart contracts line by line. Like you can plug your contracts and inspect what's happening inside of each step of it, change the variables and see how it will reflect it. And the screenshot on the right is current how it looks like. To build this product, we built our custom EVM, and we have stored all the information of networks to the system, and that allows us to build something we call simulators. Simulators allow you to simulate your transactions before even pushed to the network. You can plug and play, you can change the values and see how it will reflect in the state of the network. And one of the really common cases of our users, how they use simulators, is if some exploit has happened in the past, you want to prevent it from happening in the future, you build a patch, and before you push it to the production, you want to roll back the network state and see if your change would prevent it from happening again. And that's what they do with the simulators. With all of that, we built alerts. We are not alone in the space of building alerts. There are many of the use cases. But what we do here is we rely on the underlying technology, so you don't have to build the alerts around, for example, only events. And you can go much deeper into that and say, hey, I want to alert my system if this particular address has called this, or with these parameters and so on. So you can really play and customize to your needs. And the last one listed here is actions that we are going to cover through this session. I call it, if you want, you can create a free account and test all of these for free and much more that I didn't list it here. Cool. So this is this definition of Web3 Actions. I won't go through it right here, but in a nutshell, Web3 Actions allow you to build custom pieces of code that is low maintenance and low setup backend for your applications. And you're going to tie them to some trigger that's going to call your actions and execute them for you. And since it's a part of your backend, it allows you to don't really care about infrastructural part or maintenance part and so on. It is on us, so you don't have to do all of the heavy lifting. We've done that for you. But this is a really high level, so let's dig deeper and see what actually goes into building a single Web3 action. The first moving part of Web3 action is actually the function that you're going to build, or your custom code. It can be built using TypeScript or JavaScript. It really depends on your preferences. And it has some autonomy that how it actually looks like. The first part, it should be exported, so our system needs to take it. Then it needs to be declared in some sense. Like in this case, it has obviously the name, then it's asynchronous function, and always has two parameters, context and event. We're going to touch upon these parameters later in the talk. And obviously, the building block is your code. So what is going to happen? In this example right here, it's really simple. It's going to log something to the console, and that's it. But it can be much, much more complex. The second and the last moving part of each Web3 action is a trigger, or what is the criteria that you want to set for your Web3 action so that gets executed. It can be either on-chain or off-chain. Here you have four examples. One is the block, where, for example, we can monitor for you a mainnet and say, hey, if certain block is mined, let's execute your code. It can be like on some periodic basis, like every 4, 5, even 10 blocks and so on. It's really up to you to set up this setting. It can be periodic, so if you worked with the cron jobs, that's basically it. So you can set up, hey, let's run this Web3 action for you every 10 minutes or so. Webhook, self-explanatory, and alert. So I mentioned alerts previously in the talk, so you can tie up your Web3 actions to alerts and say, if some trigger has happened, which is the same for alert, let's execute your piece of code as well. And there actually, like this is the screenshot from our platform, so there are two ways to build Web3 actions. One is from UI, so just clickable interface for you to ease your pain of building a Web3 action. Or if you want more customizable solution, you can straight to dig into the code and implement everything yourself, which we are going to demonstrate in the example throughout this presentation. There is one more way to call your actions, which is to wait for some event in the contract, and when that event occurs, let's execute your code, and we are going to demonstrate that. So now that we know what are the building blocks and what it goes to creating a single Web3 actions, let's demonstrate how it will happen in a certain scenario. Here we have a really simple smart contract, which is if you use a Remix editor, it's automatically generated for you. But I added a small change. I added this event number stored, which returns two things: number that's stored and address, who stored that number. And it is always emitted when we call this store function. So now that we have our smart contract, let's see how to build a Web3 action or a backend for it. So the first part of building your Web3 actions is your code. What is the action function that is going to be executed based on certain event? We said that an autonomy of this function is it needs to be exported, so we have that. Then we need to define it. So in this case, it has some action function name. It's really creative. Then it's asynchronous, and it has two parameters, context and event. And it has some code. So let's explain one of these parameters, event. We talked about these triggers, what actually needs to happen so this function gets executed. And that's basically what we have here at the event. So in the first line of code, you are only basically using that event and parsing that to be as a transaction event. Transaction event is only saying, hey, let's wait for something to happen inside your contract that we are monitoring so that we get this code executed. These next couple of lines of code, if you worked with smart contracts, that's basically it, nothing new. So we are using ethers to extract information from ABI, decoding the event log, and waiting for our event called name stored. Storing that result to variable called results, which we only print to the console. So it's not more complex than the previous one, but we are just utilizing some information from the contract as well. And we mentioned that the next part of building each action or Web3 action is to build a trigger, or what needs to happen to get executed or to execute this code. And since we are building this using our code part of the platform, we built simple configuration using YAML. So if you know YAML, that's the configuration how you would provide information to our platform. I won't go into details of what each of these lines means, but basically you can set up the project name that you're using, your username, and so on, and our platform will automatically connect that to your account, and that's it. So you don't have to think about more of that. The interesting pieces of this file is this function line, which connects this configuration to the file where you created this function. So any file in the system, in your folder of choice, you will change the file name and set the file the function name that you declared. So it's up to you how you will name it. And we set up this trigger. In our case, in this case, is transaction. So if you, for example, change to execute this function when a block was mined, you will change the type to block, and that's it. Everything happens in our platform without your need to interact. If you choose to deploy this function like this, it will probably happen, but Tender will cry and say, hey, you're missing some additional information. We don't know which contract to follow. You don't know, you didn't provide any address, and so on. And that's what happens here. You can provide additional settings to whatever you want. In this case, we just provided to say, hey, we want to monitor network 4 with ID 4, and we want to monitor the contract with some address. And the name of the event is optional here, but you can name it to a number stored in our case. And that's only where you specify here, everything happens under the hood, so you don't have to change. So for example, if you tested on the test network, in this case Ringv, and then decided to go with the mainnet, you just need to change the network number, network ID, and the address, and everything stays the same. So that's it. And in this case that we went through, the real usability of this function is questionable since we are only printing something to the console. So it's not really a real world case. So let's see and challenge us to do something else. Let's see how we would demonstrate this using a challenge where we want to get a number of unique IDs or unique addresses that change the number. So in our case, in the contract, we are only storing the last address. So we don't know how many times the number was changed. Obviously, we have transactions there, but there is no information in the code. And the old way how we would do that is we would deploy the contract, set some time, like it can be a week, it can be a day, really depends on your use case, and let it run. Let your users or your system send some transaction, change the number, and we would get a lot of transactions in the system. Then we would scrape the information out with code, or God forbid manually, and store that information in some sheet or some base, depending on what you choose. After you do that, it's easy to get the number of unique addresses, but the tedious part from deploying the contract to this was basically something that I don't really want to repeat for more complex cases. So let's see how we would change and solve this using Web3 Actions. We have this action already in the previous slides, so all the code that we already showed stays the same, and we added 4 additional code lines. So we have some first code that says, okay, let's await context.storage and get some JSON with addresses, and we are adding new address to that and then putting JSON again to some storage. And to be honest, I have now more questions than I had before this slide. So what is context? We didn't explain that. What is storage? And how it can be stateless in the sense of execution and then have a storage. So let's explore that. We have this context as a first parameter to each of our action functions. It allows you to interact with two additional features that tenderly provided for you when working with Web3 Actions. One is secrets, which changes the .env file for you. And the next one is this storage. So storage is for use cases when you need some pieces of information between the execution of the function. So, for example, in this case, we want to monitor all the addresses when our event is meted. In one of the demo cases that we have for you, for example, tic-tac-toe, you want to monitor the state of the board. So you need somehow to preserve the information between the execution of the functions. And that's why we developed this storage function, which is basically key value stored, which allows you to store small bits of information for you to have and reflect that if you want to choose to call this function again. And it's pretty simple. Like in 4 lines of code, you can store the information from the contract from the event to our storage and then retrieve it back. This is how it's done. I purposely didn't implement the code where I would check for unique addresses. So if you want to do this on your own time after the presentation, go for it. And if you have problems, reach out to me in whatever media you use. And we can discuss on how to do it. Like just a hint, you can upgrade this piece of code, or you can write additional function to do just that. Great. And when your actions are deployed and in production, like some backend is using it, you can interact with all of them from your dashboard. So you don't have to go back in the code. You could, and sometimes you really need, if you want to have more flexibility in what you change. But all the necessary information can be checked and changed from our dashboard. Like you can go and update it, you can change the state of it, you can change the trigger. Sometimes you want it to be periodic, but sometimes you want to be on blockaways. Like it can happen constantly, and it can change, depends on your needs. And one of great benefits of using Web3 Actions is it's zero downtime. So whenever you change something and deploy it, your users won't feel a thing. Like for them, everything will stay the same and run as smoothly as possible. And in these examples right here, we talked about Web3 Actions and how to use them. Like this backend had only one Web3 Actions, but it can be as many as possible or as many as needed. And in some of our use cases, we had like as many as 100 in production. Behind this QR code, you have a demo folder on the GitHub where we have built 2 free demo projects right now. One is for Oracle and the tic-tac-toe, for example, which you can explore and deploy on your own. And everything is on free tier, so you don't have to pay a thing to play with it and explore how to build a backend and contracts using our platform. And yeah, that's it. I don't have the next slide. Yeah.
What's your name? Where are you? Max? Hello, thanks a lot for presentation. I haven't seen on the Tenderly pricing page like what actions are included in every pricing tier. Could you please elaborate on that?
Yeah, I think my colleague will be better candidate to answer the pricing point. I don't know all the pricing points there, so we can discuss about that after the presentation. Great, but thank you for the question.
What's your name, bud? Jason? Jason's got a question.
Hey, Lucas. Quick question. Is there any way to action things external to the system? So you say it's stateless. Sometimes I feel it could be really useful to, hit a webhook or something on a certain condition or something like that? I don't know if that's been explored.
Yeah, that's a great question. Yes, there is. Like sometimes you want to call an external API, for example, when something happens on chain. You can do it. Like that's basically why we implemented secrets version of our Web3 Actions, where you can store, for example, any API key or whatever you would generally choose to store in a .env file, and you can just call it, and yeah, that's normal. Like you can even deploy some things using Web3 Actions, but that's not recommended because of the security versions of it.
Okay, really interesting. And with actions, they start from when you like deploy the action, right? Sorry, can you hear me? Yeah. Is there a way to run like actions historically? Sort of, you know, let's say a contract's been running for over a year, and you want to maybe perform some sort of statistics on that through an action. Would that be a use case? So then you'd need to go through all the historical events.
I don't know about that case. I know that the Web3 Actions are executed in real time when something changes. Well, now, not in the future, not in the past. So I don't know if we could connect that to simulations part of our platform. I never explored that version of our use case.
Okay, cool. I mean, super interesting anyway. Thank you.
Thank you.
Any other questions? Got one up here. What's your name, bud? What is it? Gregory. Gregory's got a question. Here you go, bud.
Can you, from the action, can you call a contract? So can you do something like Gelato automation? Is it?
Yeah, you can do that.
Okay, so is it your goal to be competing with Gelato and Chainlink, or it's?
Interesting question. Let's discuss that after
Okay.
the call.
Yeah, I got the graphic ready. Does anyone have the time? Are you? I think I have one. It's 5. Yeah. 5 till 5. We can have a few questions. If anyone has any more questions, what's your name? Johnny's got a queue.
You also mentioned alerts during the presentation.
Alerts?
So could you elaborate a bit more about it? In what way one can receive alerts about on-chain events?
So if I understand the question correctly, how can you connect alerts with alerts?
I mean, do you show them in app, you need to implement it, or does it have like SNS or email or something?
Okay, that's a great question. So when you build your alert, you're choosing your destination of the alert. It can be email, it can be Discord, SMS, whatever like you need for that, or you can even call like action function or Web3 action instead, and then like connect that to the front end and inform users, for example. You could do that.
Thank you.
Anyone else? Questions? Questions for Luka? Guys, give it a round of applause for Luka. Crushed it.